Hey all, good evening. Thanks for coming here. Today we are going to talk about Azure Functions going serverless with Azure Functions, which is a serverless offering from Microsoft Azure. Just to introduce myself, my name is Vaibhav Gujral and I'm an application architect with over 12 years of experience. I'm Microsoft certified Azure architect and my MCP. I'm working with American title right now, and here is my Twitter handle and my email. If any one of you want to reach out to me, you can feel free to reach out. So this is just an agenda what we are going to cover in today's talk, like what is serverless computing. We'll start with the very basic, then we'll jump onto what are Azure Functions, what are the toolkits that we can use for developing Azure Functions, then we'll jump onto some internals on Azure Functions, which include Azure Function Runtime and triggers and bindings. Then we'll also see how Azure Functions are priced. Then we'll see deploying and monitoring as well, how we can deploy our Azure Functions and monitor those. Finally, we'll see the best practices that we should generally follow when we are developing Azure Functions and Azure Function Proxies and durable functions are upcoming features in Azure Functions, so we'll just touch upon them before concluding. So let's start with what is serverless computing. It doesn't literally mean no server as the name suggests, rather than think of it as of less of server. So our code is still deployed on a server. When I say serverless, it doesn't mean that there will be no server in the picture. Serverless computing is a cloud computing execution model where a cloud provider takes care of orchestration, abstraction of the servers, infrastructure, and operating system. And the resources are provisioned and deprovisioned only for the time when the underlying code is executed for that. So it started a few years back with an acronym called backend as a service. One perfect example for that is Auth0, which is an identity provider, cloud-based identity provider. And in last couple of years, I guess another acronym for serverless computing that is picking up momentum is Functions as a Service. So which actually means executing individual pieces of code on demand, on the fly. So we are going to cover Azure Functions, which is one of the function as a service offering from Microsoft. There are other offerings as well in the market, like AWS Lambda from Amazon and Google Cloud Functions. You can go and check it out if you are interested. There are some key benefits of moving to serverless architecture. The primary being, like most of us present here would have come across situations where we have to deploy our code and keep it running always up and always on, so that our servers can handle the requests whenever they come in and they don't just fail over. So serverless actually handles that situation pretty well by handling the provisioning and deprovisioning of the infrastructure automatically whenever our code is executed. So that removes basically the need for server management and always on server components from developers zone. So as a developer, we only need to focus on the piece of code that we are writing. And another advantage of function as a service is we don't really need to bother about the complete architecture and the complete application or infrastructure where it should be run. We can deploy pieces of code as functions and run them, execute them on fly, on demand, with our cost which are under control, because we are charged only based on how much time our code has been executed. So it automatically, there is another feature as part of serverless architecture which enables auto scaling on the fly. What I mean is, let's say if we have an Azure function running on the cloud on Azure, it automatically takes care of scaling up and scaling out and scaling down our infrastructure. What I mean is, if we have simultaneous requests coming in and our server, it measures it heuristically, and the moment it realizes it needs to bring in additional instances, it spins it up. And the moment the number of requests goes down to 0, it just spins down everything. So, and best part is we are only charged for that particular time. There are some concerns out there, like we lose control of the infrastructure where our code is running and security concerns, but I think Microsoft being a large cloud provider and their top priority is security, so I think they address it pretty well. Let's talk about Azure Functions. Azure Function is a serverless compute service offered by Azure that runs code on demand. And when I say the code that runs on demand, I refer to the code as a piece of code like we write in our C# methods, or we can directly map it from how we write our C# methods as writing in Azure Function. It's just a single piece of code which we take it from our environment and deploy it into Azure as Azure Functions and run it. Just think if you are going to write just a single piece of code for the functionality, the problem at your hand, for example, connecting to Azure storage or image processing or exposing an HTTP API or IoT, how handy it would be if we can just write that piece of functionality and expose it and move ahead. So we get that flexibility through Azure Functions. How many of you have worked on Azure Web Apps? Have you guys used Web Jobs? Web Jobs is one of the features in Azure Web Apps through which we can run background tasks in the same context as Azure Web App. So Azure Functions is nothing but a serverless evolution of those web jobs. In fact, if you will go and read about it, Azure Function SDK is actually still known as Azure Web Jobs SDK. Azure Functions offers some key features, like it doesn't support a huge variety of languages, but it supports good number of languages. Right now it supports C#, F#, JavaScript, and Java support is under preview right now. And as I said, it's a serverless architecture, so we pay per use, we pay per code execution. As the code is executed, we pay only for the resources for that particular time. Azure Functions support NuGet and NPM, so that takes care of the concerns that we can bring our own dependencies into our functions and use them as we would have used in any of our other projects. We'll talk about HTTP triggers in the upcoming slides, but we can create HTTP triggered functions which can be triggered by HTTP requests. Azure Functions supports OAuth for that using identity providers like Azure AD, Facebook, Google, Microsoft, and so on. One interesting piece of it is it's quite flexible. We can directly go log into Azure portal and spin up an Azure function, write our code in Azure portal directly. We don't need any toolkit for that. Or otherwise, if we are .NET developers, we can go ahead and write it in Visual Studio. If we are open source developers, we can go ahead and write in Visual Studio Code using JavaScript. So that brings in a flexible development environment where multiple developers having different skill sets can work together on different PCs and spin their Azure functions instantly. Last but not the least, Azure Function Runtime is open source and it's available on GitHub. If you like to go and see the code and contribute, you can go and check it out. So for the benefit of all of us who work on Visual Studio, if you want to develop Azure Functions, the primary prerequisite is you should have Azure Development Tools installed as part of your Visual Studio, which includes all the toolkits and SDKs required for developing any cloud app. Once you have that installed, ensure that you have an extension known as Azure Functions and Web Jobs, Web Job Tools, which brings in all the tools that you require for developing specific Azure Functions and Web Jobs. And finally, if you have those two things set up, then you will be able to see project template within Cloud tab under New Project for Azure Functions, just like any other project template. For all of us who work on Visual Studio Code, before we can start developing Azure Functions using Visual Studio Code, we need to have Azure Function Code Tools version 2.x, and we also need to have the language support installed on Visual Studio Code. If we are C# developers, we have to install C# support. If it's JavaScript, we should get that installed. Over and above that, there is an extension available for Azure Functions for Visual Studio Code in Marketplace. You can go ahead and install it on over Visual Studio Code to get going. Lastly, Azure Function also provides some code tools, which are command line based tools, which comes in handy if you want to develop, test, debug, or deploy your Azure functions locally and test them out. Right now there are 2 versions available out there. I have given the command lines to install those, and as you can see, version 1.x is only supported by Windows, whereas version 2.x is supported across platforms including Mac OS and Linux. And the underlying reason for that is it's based on .NET Core, so we need .NET Core for version 2.x as well. So let me quickly jump onto quick demos. I will quickly show how we can create Azure functions on Azure Portal and then through Visual Studio Code and then Visual Studio. Oops. I'm connected through my hotspot. Let me figure it out what's going on. Okay. So here I'm into my Azure Portal dashboard. So if you want to create a Azure function directly from Azure Portal, it's very straightforward. You can go ahead into create a resource. For the benefit of saving some time, I already have created a resource group under which I want to create all the demo functions. Plus I've also created a storage account in that, which actually stores all our files which are picked up and executed whenever we want to trigger our functions. I'll go ahead and click on function app, go ahead and create it. So function app is an umbrella offering under which we can create a number of functions. I'll go ahead and give it a name. I'll use the existing resource group that I created. It supports Linux, which is under preview right now. We'll stick to the Windows for the demo purpose right now. And under hosting plan, we'll be talking about it in the upcoming slides, but you can see there are a couple of these. One is consumption plan, which makes it truly serverless. The other one is app service plan, because function app is part of app services. I'll keep the location as central US, which is location for my resource group. I can choose runtime stack as either .NET or JavaScript. Java is right now under preview, so I will, being a .NET guy, I will keep it as .NET for now. I'll use existing storage account that I created it for demo. We can enable Azure Function supports monitoring and logging through Azure Storage directly. But over and above that, we can also go ahead and enable App Insights, which gives us a telemetry view of the things, how things are going through our Azure functions. So I will go ahead and enable it for this for now. It takes, I think within a minute it will create a new Azure function for me. So in the meantime, what it does is it creates a umbrella function app. It doesn't create any functions within it. It's just creating a function app within an app service. So once it's created, I will show you it still refers to that function app as an app service, though the logo still represents a function. So it's created. Let us go to the resource. So once you reach that page, the pane for a function app, you can see it lists down a tab called functions. As of now, there is no function in it. I'll go ahead and create a new function. It gives me an option to go ahead and create either an HTTP trigger or a different triggers. I can choose one of those. We'll talk about it in upcoming slides. For now, I will just choose HTTP trigger and name it HTTP trigger. Authorization level is anonymous so that anyone can access it. For now, I will go ahead and create it. It automatically creates the underlying code for me for the function, which I can go ahead and edit it within the portal itself. You can see here the extension of my file is .csx, which is C# script, which allows me to write my function using C# within Azure portal. So you can see it has created a function for me. Pretty straightforward. It's a web API action for me, which takes in a HTTP request, it processes it and returns back a message. It is right now it just logs the information. I will go ahead and view the files that it created for me. So it has basically created a function.json which holds all the triggers and binding information. I will show it to you in upcoming slides as well. And this is our run.cx. I will quickly go ahead and test it out in the portal itself. I will go back and run it. It's probably resolution issue that I cannot scroll it back, but it shows the status and the response below the request body. Sorry about that, but it's working. I cannot show it because of resolution right now. So that's as simple as this. We can go ahead and create an Azure function using the triggers that we want. Let me quickly spin up a Visual Studio Code instance so that I can show you how we can do the same stuff using Visual Studio Code. So I am into, anyone knows how can I change the theme of Visual Studio Code? Or black is fine. Sorry?
On the right side. Under custom, yeah. Color scheme. Excellent.
Oh, okay. All right. So I have all the Azure .NET Core tools installed with .NET Core, so which enables me to see a tab here for Azure. I'll go ahead and since I have already signed into my Azure account, it already shows my Azure subscription here. I'll go ahead and create a function, create a new project from here. Oops. I think the resolution is really messed up for me right now. I don't know how do I select it. All right, I go and select the folder where I want to create my project. As soon as I select my working folder, it asks me the language that I need to use to create my function. I go ahead and create it. I choose C#, it finishes creating my project. I go ahead and create it, add it to my workspace so that I can start working on it under my workspace. It says there are some unresolved dependencies because I've chosen C#, so I can go ahead and restore my dependencies here. Once it's done, I go ahead and create function. It asks me which working directory I want to use. I go ahead and choose the one which I just created. I still don't know how to. Oops. Interesting. All right, I selected that folder. Then it asked me which trigger I want to use. Similarly, how it was showing it in Azure portal, the inbuilt trigger. So I go ahead and I will choose the HTTP trigger there itself so that I can replicate the same thing that I did it on Azure portal. I will go ahead and name it as HTTP trigger 1 and press enter. I can give name of my company. Sites, whenever we are trying to access our functions, HTTP triggered functions, we have to have an authentication key in place, an API key in place to make it secure. Though it's not meant for production use, but for testing purposes, we need to have. I'm keeping it as anonymous right now so that we don't have to go through that route. But if we set it as a function key, then we can keep our individual functions secure using that function key. If we choose the admin one, that works across the functions and that links with the function app. For now, I will keep anonymous there, and it creates all the code for me. Pretty much the same code that it has created on the C# script file on Azure portal. I will go ahead and run it. All right. So it builds my Azure function and it will start it. Interesting. Sorry? Oh, probably it's not getting any IP right now. Hey Brian, do we have a Wi-Fi here that I can use? Okay. Let me see if it works now. It's already in use. Let me try it once again. Bad luck. So basically I was doing some practicing these demos at home. I can show you how it behaves. So I was trying to test it from Postman. So once my API function was up, I could go ahead and hit the URL, make a post call on that. I was passing a body with, it only accepts name right now so that it can display back the response with the name. So the moment I was posting with my name, it was returning it back with hello web help. So I think this is still up on Azure, which I was trying before coming for this session. Let me see if it works pretty much. It works. So I can probably try it out the same way with the function that I have deployed through Azure portal. But let me show you first how we can, assuming our function works fine locally, which it is not working right now, but once it starts working, how we can deploy it back to Azure. I will go here under the Azure pane again, and I will select my subscription, and you are seeing here a upload symbol which says deploy the function app. I go ahead and select it. It asks me for whether I should create a new function app or I need to override an existing one. I go ahead and create a new one. It asks me for a new name. I give it a name. It asks me whether I need to use existing resource group or a new one. I will go ahead and use the existing one. Same for the storage account. And it deploys it. It creates first the function app, and within that it deploys the function. I will show you what's happening in the Azure portal in the meantime. I'll go to the all resources. I will pull up my resource group. So here you see this is the one which is getting deployed right now from the Azure function. It already created the new function app, and it's not deploying my individual function that I have developed there. I'll click on this. So the moment the deployment is complete from the VS Code, I could see my function getting set up here. So it says it's completed. I can go ahead and verify the output, and it says my function is accessible from this URL. I will test it out in a moment. And here is our function which we just deployed. The change and difference you will see in this particular Azure function from the one that we created from Azure portal is this one is disabled for editing in the portal because we have developed it locally using Visual Studio Code, and that applies the same for the functions that we develop using Visual Studio. Under the integration tab, you can see the function.json, which defines what type of trigger and bindings it has. We'll talk about those in a moment. These are the function and host keys that I was talking about, the access keys for my API. If I want to if I'm not using anonymous and I'm only using function key, I need to go ahead and create a new function key here. Otherwise, it's a host key, and the key that you are seeing here called as _master. This is a full privileged key, so ensure that you don't share it with anyone else because they might abuse your functions then. Lastly, monitors, since it was deployed through Visual Studio Code and I have not configured app insights beforehand, but it gives us an option where we can go ahead and configure app insights for our telemetry purpose. Let me quickly go and grab that URL. So it comes back fine, it returns 200 and okay, and likewise we can actually go ahead and create any HTTP post and get calls that we want pretty easily. Let me go to Visual Studio as well. I've already installed Azure Function Extensions over Azure Development SDK. I'll go here and under Cloud I can see Azure Function app. I will go ahead and create it. I won't deploy it because that's pretty much the same what we did from Visual Studio Code. But here the experience is different. It asks for the trigger that we want to choose. Let us choose HTTP trigger, which we have been doing for other demos as well. It asks whether we want to use the local storage emulator for local testing or if we want to use a storage account. I'll go ahead and use my storage account. If we want a new storage account, we can go ahead and create from here. Otherwise, we can go ahead and choose it from here. It shows that there is a Omaha MTG demo storage account which I already created. I will go ahead and use it. And we already talked about the access rights. I will keep it anonymous for now. And it pretty much does the same thing that we were seeing in VS Code and Azure Portal. It spins up a function for us. So it does pretty much the same. It accepts a name parameter and returns back the response. I'll see if I can run this locally and show it to you locally if it works. So it's failing because I think I already have a function app running on 7071. Never mind. So that's about the demos. Let's jump onto the presentation. So as you can see, we were seeing different triggers there. So it's pretty implicit since Azure Functions is a part of Azure ecosystem. It supports Azure services and some of the third-party services also through which we can integrate. These services can be used two ways with Azure Functions. Either they can be used to trigger execution of an Azure function, or they can be used to provide input or output data for our Azure functions. So some of the services that we can integrate with includes Cosmos DB, Service Bus, Topics and Queues, Event Crates, Event Bus, Azure Notification Hubs, and from third party we can connect to our on-premise resources via Service Bus integration, or another one which I liked about was Twilio, through which we can have SMS integration through our Azure functions. What are triggers for Azure functions? So I was pulling up definitions in Merriam-Webster, and one of the definitions said a trigger is something that acts like a mechanical trigger in initiating a process or reaction. So that is pretty much true for Azure function trigger also. It basically just defines how a function is supposed to be triggered. And there is a function can only have one trigger, so please keep in mind, because it can be triggered only by a certain specific event. So being that said, why triggers are useful? Triggers provide us out-of-the-box templates to create triggers for so that we can execute our functions. So when I say out-of-the-box templates, you would have noticed that when I was creating Azure functions, it was already showing me HTTP trigger, blob trigger, service bus trigger, and all that stuff. So it automatically encapsulates everything. I don't need to do anything if I'm connecting through Azure blob storage, and using blob trigger, it automatically sets it up everything for me. So that it provides all the out of the box templates for me for all the common scenarios. Any trigger that we have has a direction. For example, when we are writing a C# method, it has function parameters, and a function parameter can be incoming parameter or it can be an out variable. So likewise, a trigger can only be in variable. We cannot return back something to the trigger. And a trigger can also have some payload, like the way we were sending to our HTTP trigger, we were sending a payload with it, which was a JSON payload. Likewise, we can send any payload. For example, if we are working with blob trigger, if we are in a scenario where we are monitoring our blob storage account container, the moment any document is uploaded in that, we can pass on its content as the payload for our trigger. These are some of the triggers which we already have seen. It pretty much lies on the lines of the supported services that Azure Functions has. HTTP trigger, we already tried it out. Timer trigger, if we want timed executions of our code. Cosmos DB, the moment we have a new record added into Cosmos and we want to trigger some functionality, we can utilize Cosmos DB trigger here. Blob trigger, as I said, if we have a file getting uploaded or deleted from our storage account, we can trigger an Azure function to do whatever processing is required. Queue trigger, whenever a message is posted in service bus, Azure Azure storage queue, it triggers an Azure function. Likewise, event grid and event hub triggers are used for eventing purpose. Service bus queue and topic are used pretty much on the same lines as queue trigger. After triggers, another concept that we need to understand before starting working on Azure Functions is bindings. As we understand, triggers provide the entry steps for our functions. They trigger execution of the functions. Bindings provide the data on which our function should work on. They provide a declarative way. So that we can consume our data from different services, process them, and return it back. When I said declarative way, those of you who are familiar with C#, we can specify our bindings using attributes, which is pretty much the standard way of having declarative programming in C#. Unlike triggers, bindings are optional. For any Azure function, we need to have a trigger to start the execution, but bindings are optional, and it purely depends upon the functionality that we are trying to implement. There could be two types of bindings, input or output, as we can either fetch data from our sources, for example, Cosmos or Blob or whatever it may be, or we might return it back to those sources. And there is no limited number of input and output bindings. We can have multiple number of input and output bindings in our Azure functions. We'll come on to runtime versions in the upcoming slides. I was showing you the function.json file created in the portal. So it pretty much looks like here. If you will notice here, it's a JSON file with a bindings array in that. That bindings array has two items in that right now, and this function.json is a example of Azure function which has a queue trigger, and the moment a message is written into our Azure storage queue, it inserts a new row into Azure table storage. So on the first element, you can see the type is specified as queue trigger. The queue name is specified under the queue name property, which indicates that this is the queue, and the connection string is given under the connection type, property type. Direction you can see for the trigger is always in, as I was saying, and the name suggests the input parameter that we will be getting the message from the queue into our function. Likewise, in the second object, you can see here the table name to which we want to write our row into. Connection shows the connection to our table storage. Name, you will notice here it says $return, which indicates that we want to read the queue message, process it, and whatever we want to return it back, we will return it back as a return value of our function. And $return, what it does is it basically fetches that return value and stores it in the table storage. And its direction is out because we are sending it out of our Azure function. Likewise, we can have even input bindings as well if we want to capture data from other sources as well. This is pretty much when I was saying bindings are declarative. This is pretty much how we can set those up in Visual Studio. So you would have noticed when I was creating Azure function in Visual Studio Code or Visual Studio, I didn't work on function.json. I was directly working on C# file. So basically, when I was creating my function, it automatically has created some attributes on my function. You can see here the function name attribute, which indicates the name of my function. Under that, it says return, and it shows the table connection string and the table name where the output row has to be inserted. Likewise, within the function signature, you will see an attribute called queueTrigger, which has the queue name and the connection string for that. And when we build this and deploy it in Azure functions, it automatically translates this information into function.json. Similarly, this is a JavaScript code. If we want to do it, it specifies under the context object in JavaScript. If anyone is aware of JavaScript. Another interesting concept around binding in Azure function is if we want to provide those values at runtime, or we want to make the values configurable. For example, I want to read a document from my blob storage, and I want to pass on the container name at the runtime. So we have different mechanisms through which we can pass those as expressions and read them at runtime. One of the common example is app settings. Like it works in web apps, we can read our bindings from app settings, or we can read from different other mechanisms as well. Most of the expressions are actually identifiable using the curly braces. If we are passing curly braces, you can identify it's an expression and it's not an actual value. But if we are trying to read it from app settings, we use percentage signs rather than curly braces. Some of the types of binding expressions that we can use includes app settings. As I said, I will show it to you how we can do it. Trigger file names. For example, if I'm uploading a file in my blob storage with the name abc.xyz, I can read that name and I can use that name as using trigger file name. Trigger metadata, when we are posting we are triggering our functions, it also has some metadata which we can use. So using trigger metadata, we can use that extra metadata that we can create for our triggers. JSON payloads, I have shown you how we were posting it on the HTTP, where we can read the incoming JSON payloads and configure our values. New GUIDs and current date and type is pretty common, where we want to randomly generate names or the settings. We can use either new GUIDs, and if we want timestamp values, we can use current date and time using date time value. When we are creating Azure functions, I missed to show it to you when I was creating function in Azure in Visual Studio. It actually gives us an option to either select version 1.x or version 2.x. I did touch upon this initially when I was talking about Azure core tools, which also come in 1.x and 2.x versions. So on the same lines, Azure function runtime version 1.x is only supported on Windows, whereas version 2.x is supported on Mac OS and Linux also. The underlying reason being the same, that it is based on .NET Core. .NET 2.x is the current version, though both 1.x and 2.x are supported for production right now. But 2.x is the current version which receives all the updates from Microsoft right now. There are a few benefits from 2.x compared to 1.x. Like in 2.x, they have actually segregated bindings from the runtime. In 1.x, whenever we are creating our Azure function, it was not a lightweight mechanism, because even if we are using only HTTP trigger-based bindings, it used to still include blob, service bus, and all other bindings in the package. But the advantage in 2.x is they have actually moved out of all the bindings and made them as extensions. So we can install the bindings as extensions, whichever we need. If I want to only work with blob, I will go ahead and only install the extension for blob binding. There is an exception to it. HTTP and timer is still included in it, but it is still lightweight. Quickly, I want to touch upon the language support on both these frameworks. As I was saying, C#, JavaScript, and F# is supported through both the framework versions, but Java is under preview in only version 2.x. It's not available in 1.x. There are some languages which are in experimental phase in version 1.x, and since 2.x is the current version and they don't support it right now, so I don't know if Microsoft is really going to carry forward those supports in 2.x at all. This was what I was talking about, that how we can register our extensions, binding extensions now. It was not possible earlier in 1.x as such, but it is not supported in 2.x. If we are not working through Visual Studio, we are using it through Azure portal, it's automatic. Same with Azure function core tools through which we develop in Visual Studio Code. Earlier in 1.x it was automatic, but in 2.x we have to use the CLI. And through Visual Studio it's through NuGet packages. We can install the NuGet packages, and the moment we install it, it registers that extension for us in our function. Some of the bindings which are supported across the versions include blob storage. It pretty much falls in place with the same services that Azure Function supports on Azure. Blob storage, Cosmos, Grid Event Hub. External file and external table is something I'm interested in, but it is, I think, still in preview, because I have worked on a situation where I wanted to have a file share, an on-network file share, and I wanted my Azure Function to be connected to that, as and when I place a file on that, it should read that file and send me an email. But I was not able to do it in 1.x. But I was reading yesterday, and in 2.x they say it's under preview, so I'm excited. I think we should be able to do that now. HTTP are already seen. It has some support for graph as well. I never tried it though, so that would be worth checking it out in 2.x. Mobile apps, notification hubs are not supported in 2.x. It is still supported in 1.x. Queue storage, SendGrid. SendGrid is one which we can use for sending emails pretty much through Azure Functions. Service bus is supported across both the versions. Table storage, timer, Twilio all are supported through both the versions. Webhooks are not supported through 2.x. Now the interesting part which makes Azure Functions actually serverless. So when I was saying that function apps are actually part of app services, so there are basically, when you create a function app, it gives you an option to create your function app as part of an existing app service plan, or you can very well create a new app service plan as well. Now, if you understand how app service plan works, is whenever we deploy an app service, we decide what app service plan we want to deploy it into, because based on that it identifies the resources on which our app service will go and get deployed. So it's it doesn't makes me think that it's going to be really serverless, and that's true. The actual benefit that we get out of using app service plan, probably I should jump onto. So this is what I was saying. It's pretty much same as we have it for app service, but the advantage we get out of using app service plan is, consider of a scenario where you already have a web app or an app service running in an app service plan, which is not utilized 100%, and you have some resources available there. So rather than spinning up a new app service plan for function app, you can go ahead and utilize the existing app service plan, because anyways your function code will be executed only when you trigger it. So your overall costs will not be anything additional, because you will already be paying for your existing app service plan. And it works pretty much same as it works for web apps. We can manually set the scaling features, or we can enable auto scaling on it. We can run our function apps on the same lines as a web app. But the interesting option that we have for pricing for Azure Function is the consumption plan. Consumption plan makes it really serverless. It ensures that whatever resources it needs, it automatically provisions and deprovisions those resources. The moment we trigger our function, it provisions the resources, executes the code, and deprovisions it. It really makes Azure Function serverless. And another interesting thing to understand about consumption plan is it doesn't handles individual functions, rather than it handles function app. Function app can also be called as a function host because it hosts the different functions. It hosts the runtime, which manages all the functions running in our function app. So whenever under consumption plan it scales out or scales down our resources, it scales out or scales down the complete function app and all the functions running in that function app. There are some limitations for each of the function hosts. That first and foremost, it's limited to 1.5 gigs of memory, and I already touched upon that all functions within function apps are scaled out and down. They are stored on Azure File Storage, which is based on Azure Blob Storage. That's why we created that Azure Storage account, where it can go and dump those files, and whenever we execute our code, it goes to the file share, picks it up, executes the code, and dumps it back. At maximum, Azure Functions times out after a configurable period of time. By default, it is 5 minutes, and maximum we can set it to 10 minutes. So one key criteria to look for whether we should really use consumption plan or not is to understand whether our function is going to be executed for more than 10 minutes or not. So if it's going to be executed it's going to take more than 10 minutes to execute, then probably it doesn't fit into consumption plan. And other option is we can go ahead and break our function into smaller functions which can execute into smaller periods of time. So as I said, under app service plan, we can configure manual scaling, or we can manage auto scaling, through which it will scale out or scale down the instances. How it works in consumption plan is there is a component called scale controller within consumption plan. What it does is it measures the heuristics of the events that is triggering our function, and based on those heuristic data, it identifies whether it needs more instances of the function host or not. So the moment it sees there is no event triggering our function, it scales down everything to 0 and our function is not running anywhere. The moment it starts receiving events, it spins up instances based on the number of events. To give an example, let us consider if we have a queue trigger where we are seeing if a message is received on a queue, it should trigger our Azure function. What scale controller does is it monitors our queue storage. It sees basically two data. The first data that it monitors is the number of messages on the queue and the age of the oldest message on the queue. Based on that, it decides whether it should spin up more Azure function hosts or not. A single function app can scale up to a maximum of 100 instances, though I have never seen under what scenario, because I have not really worked on those production scenarios where it will reach 100 instances, but I think that's pretty much a limit on consumption plan. At most every 10 seconds a new instance can be created under consumption plan, which anyways is taken care automatically, so we might not be aware of that when we are working on functions. So this is pretty much how it sits into the overall big picture. We have our events on the left side, and which keeps on triggering our Azure function. In between sits the scale controller, which keeps on monitoring the events, and based on the heuristical data, it keeps on spinning up or spinning down the number of function host instances. So interestingly, it doesn't work the same way. The billing doesn't work the same way like app service plan, where it's underlying compute resources which are charged per hour, or the memory is charged per gigabytes. Under consumption plan, they charge it under a unit known as GBS, which is gigabyte seconds, where they include, basically they consider the time for how long our code has been executed and the memory and the compute resources it has used for that time. Based on that, they have devised a unit of measurement called as GBS, through which they measure and they bill us. And again, we are built based on a function app level and not on an individual function level. Some questions we should ask before deciding whether we should go with consumption plan or app service plan. Some of them might be whether the existing resource can be leveraged. To be precise, whether the current app service plan can be leveraged or not. Is the function supposed to run continuously? If it is that, it makes much more sense to put it on app service plan with always on. What are the CPU and memory requirements to run the code? As I was sharing earlier, that under consumption plan, we can only have 1.5 gigs of memory. If we need more memory and more CPU requirements, we should probably go with the app service plan. Will the function app run more than max execution timeout under consumption plan, which is 10 minutes? If it takes more than 10 minutes, we should probably go with the app service plan. And if we really need advanced features of app services like VNets or ASEs, then we should probably go with app service plans. Whether the code needs to run on Linux, Windows, custom OS images, that can also be a deciding factor for us. Again, irrespective of the hosting plan or the pricing plan that we choose for, but implicitly it creates a storage account irrespective of if it is consumption or app service, because it stores the underlying files in that storage account. So we are anyways charged for that storage, irrespective of if our code is ever executed or not. Always on. For those of you who have worked on web apps, there is a feature called always on, which we can enable on app services to keep our services never dying on our Azure resources. So under app service plan, function app goes idle after some time. So ensure that when you have mission critical functions running under app service plan, you go ahead and check always on option there, so that your function never dies and never goes idle. Under consumption plan, it takes care of it automatically. Functions are activated automatically. But if you are using blob trigger under consumption plan, it takes some time to warm up, which is roughly around 10 minutes, and I have faced that. I have set up a blob trigger function for my project, and it was working fine one day, and next day morning when I came, it was not working. It was throwing 500, and I was not having a single clue what's happening. Then I figured it out because I have hosted that in consumption plan, and since it was not used, it has gone into an idle state. It has consumption plan has deprovisioned all the resources, and hence it takes 10 minutes to again warm it up. So after 10 minutes, when I have placed again, it has started accepting my request, and since then it worked full day. So what I did was I have created a new function app under app service plan with always on for that scenario, because once we choose the pricing plan, we cannot change it. Once it's consumption plan, it sticks with consumption plan. I've touched upon this about how we can monitor Azure functions. It supports inbuilt logging through Azure storage, and I was showing you before how we can configure app insights as well for advanced telemetry. Since Azure functions are based out of app services, it offers us the same options we had for app services and web apps for deployments. We can set up continuous deployment through our source controls. I will show it to you after this slide. I have a demo for that. And other than that, it offers pretty much straightforward deployment methods, like we can deploy it through zip files, we can deploy it through ARM template, or we can actually log in into Kudu and log in into the actual directory structure and copy our files directly into that, and it will identify the functions over there. Let me go to the Azure portal once. So here, if you will go into our function app, how it distinguishes between a function app and a normal app service plan are these function app settings. These are not present for app services. If you will click on this, it will give you the specific settings it has for the function app. So you can see here, since it was deployed from Visual Studio, it says it's read only. These are specific settings for our function app. But if you will go back, I would like to pick up another function that I created before. Probably this is the one. In this particular demo, what I did was I was passing connection strings for my blobs trigger here, the function that you can see over here. What this blob trigger does is it reads my connection string, which is under this app settings. It picks up that connection string. It goes ahead and reads the container name from my app setting, and it picks up whenever I upload a file to my blob storage, and it displays the size of that name and size of that uploaded file on the log. I'll quickly show how I can monitor it. So it has, before coming here, I tried running it twice. So it shows me what all it did. It said it started the function, it completed, and here's the output for it. So basically I have uploaded a PNG file with this name and of this size. The moment I was uploading, it was picking it up, and this is a pretty basic demo, but we can go ahead and do lots of things around here. Likewise, if you will go back to the function app, I have configured it through for continuous deployment through my Visual Studio Online account. So I created HTTP trigger first, and then I have deployed it. It works pretty much the same way how we deploy it through VSTS for our other projects. I'm going to show you one more thing here. This is pretty much the settings under the platform features. These are the same settings that you can see under app services settings. So there is no difference from there. You can go here and check out Kudu from here. This is our Kudu running on our function app. We can go ahead and execute. This is our function app sitting over there, and this is our function.json from where it fetches those bindings and trigger settings. Okay, one last thing. I will go back to my resource group to show you how consumption plan is created. So you can see here it still points my function apps as app services, and the consumption plan under which I have deployed my function apps are also referred to as app service plans. But how they are different from normal app service plans is you will see the option to scale up and scale out and networking is grayed out, because that is taken care automatically by the scale controller. Also, if you will scroll a little bit to the right, I don't see that, but it does says that it has a consumption model for the app service plan. Jumping on to the presentation. Some of the best practices that we should keep in mind when we are developing our Azure functions. We have already talked about it, that we should not have long running functions, because obviously under consumption plan we have a limit of 10 minutes, but ideally our functions should be small enough so that they can be executed pretty fast. If we have functions which are which take long time to execute, probably we should refactor them into smaller functions so that we can have multiple smaller functions. We should use Azure storage queues, which is possibly true with most of the intercomponent communication that we have in our system. So when we have to interact between multiple functions, we can utilize Azure storage queues for that. Functions should be stateless and idempotent if possible. What I mean to say is, if we are running our function, we have set up our function to run for a particular scenario, it should be able to run for it with the same result at any time. We should try to use our existing connections as much as possible within our function rather than creating new connections every time. We should not mix test and production data within the same function app, because that messes up things. We can use async code in our functions, but as with any other case, we should avoid blocking calls. We should avoid calling .result and stuff like that. Batching, whenever we can batch our messages, batch our events, we can actually get our functions to be more efficient, and we can get best of our cost. We should write defensive functions. What are defensive functions? When I am writing a function, it should not fail, number one. If it fails, it should know where it did fail, and next time it should be able to pick it up from there. At the base level, I should have try catch in my functions, and then I should also handle error handling through my sources. For example, blobs, service bus, all these are accessible over HTTP now. So quite possibly we can have network issues, we can have timeouts. So we should address all those scenarios so that if there is any error or any failure in our Azure function, it should be able to continue from there. It should not be a blocker on that. Durable function. I was telling in the previous slide that Azure functions are designed to be stateless. Whenever we are writing in an Azure function, it doesn't hold any state, because it takes the state from one source, process it, and passes on to the other source, and controller actually scales down everything when incoming events are stopped. An extension of Azure function is durable functions, which offers statefulness. It provides a stateful orchestration of function execution. So it's based on, actually there is an open source framework known as Durable Task Framework, which is available on GitHub. So it's an serverless evolution of that framework through which we can make our functions more durable and more stateful. Some application patterns where we can use for durable functions include function chaining. Probably I will, these pictures show it pretty much. In function chaining, we can chain our functions in a sequence. We can execute those functions one-on-one in sequence. Fan out, fan in, we can execute our functions in parallel. Async HTTP APIs, we have the long-running actions triggered by an HTTP call and then redirect the clients through another function which can get a res status of the existing HTTP call. Human interaction, there might be workflows where we might need human interaction, so we can implement human interaction pattern as well using durable functions. That's pretty much very basic about it. It's recently been launched, and I've never tried it so much right now. Last thing for today is Azure Function Proxies. We can create these proxies to break a large APIs. Basically, I could understand it on the terms of microservices, how we used to divide our monolithic systems into microservices. This applies to our APIs. We can break down our APIs into individual functions, and to the client it still appears as a single API, but under the hood it creates a proxy which again calls all the different functions. So I've tried to show here a screenshot. I didn't try it yet, but within function app there was a tab called functions where we are seeing all the functions. Just below that there was a tab for proxies where we can go ahead and create proxies and set up all the API proxies that we want for our REST-based APIs. So quick summary, what we talked about, what is serverless, what it does. It's an abstraction of servers. It doesn't mean no server, but our code still runs on server, but it means less of a server. What are Azure Functions? They run on, it's a serverless offering from Microsoft where we can execute our pieces of code. There is rich toolkit available for Visual Studio and Visual Studio Code developers. Triggers, Azure Function triggers are the mechanisms through which we can trigger execution of our functions, and they offer out-of-the-box templates for some of the common scenarios like blobs, queues. Bindings provide input and output payloads that we can use for our functions for execution. A couple of hosting plans that Microsoft offers us for hosting our Azure functions: consumption plan and app service plan. Azure Function supports continuous deployment through different source control providers. I'm sorry I missed that to show it on the portal, but it supports GitHub, Visual Studio Team Services, Bitbucket, and so many others. Azure Functions have built-in support for App Insights as well for monitoring, and upcoming features in Azure Function space are durable functions and function proxies, which we should be checking out. If you want references or any further readings that I refer to, you can check out these links. Any questions? Yes.
Do you use it not only for communication through functions within your own application, but also to reach out to other companies and try to do electronic data interchange?
We can pretty well do. We are not doing it, but we can pretty well do it because the demo that I was showing, it was HTTP based. And it's accessible on internet, but we can still control it through function and admin keys. And I have mentioned it initially that through those HTTP triggers, Azure Function does support OAuth authentication. So I think whenever we are exposing it to anyone outside our organization, we should get that OAuth authentication in between so that it is not misused, but I think we can use it. Is there a?
When would I know to make a microservice or to make a function instead? The size of it?
I think microservice and function differs in like if it's a class or it's a method probably. Anyone else? In my project, we are using VSTS for deployments, and we are using build and release pipelines for that. So we are utilizing the web app task under release pipeline for deploying our function apps because under the hood they are same as app services. But what I was trying to say about continuous deployment in this presentation was if we don't have build and release pipelines at our end, we can actually go to Azure portal and set up continuous deployment by providing our source control credentials over there and attaching it to the repository we want to connect it to, so that the moment we push any change in our repository, it automatically deploys it. But we are doing right now the same stuff through VSTS build and release pipelines as well. For in release pipeline, we didn't see any specific task for function app, but we are utilizing web app task for that because it essentially does the same thing.
So how about the transforms? Transforms for different environments, so we configure in the build?
So we have it automatically picks it up when you are seeing those app settings in there. So when I was saying we should have different functions for non-prod and prod, this is what it meant. So when we have different function apps, will have different app settings automatically. Yeah, but we are doing transforms in our, I can show it to you. When we are deploying our function apps, locally when we are developing it, there is a file called local.settings.json where we store all our app settings. So we are transforming that when we are deploying our function app. You're seeing the local.settings.json file. So under our release pipeline, we are transforming this one. Anyone else?
You mentioned one scenario where there was a several-minute warm-up time. Is that always the case, or if my function is using the consumption plan,
It's under the
shut
consumption
down, like I haven't used it in a while, and all of a sudden I need it, is there always a warm-up time
for blob triggers.
for block triggers? Is the only scenario? So if you're triggered by HTTP requests,
Mhm.
have that warm-up?
No.
Is there any warm-up time?
It 10 minutes
Well, just for any trigger, or just block?
for blob trigger. For HTTP, it was pretty quick. I didn't notice it. There might be few milliseconds, but something measurable was for blob trigger, and even Microsoft has mentioned in their documentation that blob triggers take 10 minutes to warm up.
Another question, is there any way to monitor the scale out or scale up?
I haven't figured it out yet, and
Do you monitor to see, well, it scaled out to this?
I haven't figured it out under consumption plan yet, and I'm not billing administrator for my project subscription, so I really don't know how under the bill they actually provide all the details. If they provide it based on different instances it has created at different times, or they just give GB seconds measurements. But I will check it out.
Your cost measurement, right? Gigabyte second?
Yeah. So I'm not sure if they really specify based on time usage or how many times it was executed and how many instances were created for each execution. I don't think so they will be providing it. They might be. But yeah, that warm-up is only for blob trigger for now. And under app service plan also function apps goes idle after some time. So that's why if we are deploying under app service plan, we should always have them set as always on. All right, thank you.